Now, as I mentioned in the last video, we would like to talk about something called a stack and a stack pointer. And we'll have a few extra commands in order to run this thing called the stack. But we can't actually get on to the stack video until we've completed this one video here. So the stack video will actually be the next one, okay? So in this video, what we want to do is, in order for us to understand the stack pointer and a few other of the things that we're going to add into this design, it's much easier for me to describe these changes if we move a few iterations forward in the design. Now, this isn't an excuse and it isn't a cop-out or anything. In order for us to understand the computer and the extra functionality we're going to add, it's much easier for me to add the functionality in and then to go back and describe each of the individual blocks. In that process, it means that we will have added in all of the extra functionality. So it means that we can look at, for example, the stack and the stack pointer, but in order for us to see the stack and the stack pointer working, we have to add in extra functions within the ALU. Now, in order to add extra functions into the ALU, we have to add extra functions within the control unit. Okay, so it's much easier for me to build up what is nearly a completed version, and then you'll be able to see the stack, pointer and other parts of the functionality which I'm going to show you over the next few videos. You'll be able to see them working in situ the way they're meant to work. Okay, so it's much better for me to do that than to build in tiny little bits individually, because it would just get confusing for you, and it's extremely difficult for me as well to build it up in that manner. So that's the reason for doing this, and it's the reason for this intermediate video, so that we can have a quick look over the new circuit. Now, don't get worried. As I said, all of the changes that have been made from the last circuit to the new circuit will be explained over the next 4 or 5 videos, and they'll be really quite interesting videos, I believe. So having said that, you'll notice in the resources section we've got 2 of our Logisim files. One of them is just the same as the last video, okay? Because we want to make a comparison between that and the new design. So the other one there is the new Logisim design. So you can go ahead if you want and open both of those up. And what I'll do is I'll talk through in a kind of broad brush sense the changes that we've made, okay? But again, don't get worried. This is just a lead-in video, and we'll go through all of the changes in detail over the next 4 or 5 videos. So you can go and open both of those up now and come back and we'll talk through some of the changes. So this is the original design, okay? So this is as far as we've got in our computer design. We had our registers, our input-output, flags, a reset end clock and our motherboard. So the new design is going to look like this. So again, don't get freaked out. We will go through all of this over the next few videos. So the top level is not that much different. We've still got the motherboard, although I've now called it a computer. We've got our flags, we've got our control, and we've got the clock here. We've got the registers down the bottom, and the only difference is that there's more of them. Previously, we only had 4 registers, okay? Now the registers in totality here is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, so there's 12 registers here in totality. So the top level here is not an awful lot different. The only differences are I've added in a display, a keyboard and a graphics unit. And we'll do 2 or 3 full videos on these and how we install them and how we put them into our design. Now the display and the graphics unit are actually separated because the display is really characters, so it's typing in ASCII text, okay? And the graphics unit is, as it said, it's actual computer graphics. So they're separated here within Logisim, and the keyboard is self-explanatory. So that's our top level here. Now the top level, we'll have a look inside the actual computer. So here's a computer here. So let's drop inside. Now this level here is pretty much the same as the previous iteration. There's not an awful lot of difference. We still have the CPU, the ROM, the RAM, and we have our input-output devices. The only difference is now that one of the devices is called a keyboard, the other is called a display, and there's 2 here for 2 different graphics units. But it's pretty much the same. There's just a few extra outputs here at the CPU. So I'll zoom in a little bit. Okay, so you can see here it's pretty much the same. And through the rest of the course, this level won't really change very much. So let's drop into the CPU. So you can see here, if I make it a little bit smaller, you can see that the connectivity is really the same. We have our control unit, an ALU, our temp, our bus, our accumulator, instruction address register, instruction register, the memory address register, and the start of the address bus, and the start of the control bus here, and our flags, and so on and so forth. So all of this is pretty much the same. Now the only difference between this one and the previous version is that, or one of the main things, is that we've got a whole load of extra registers. So previously we only had 4 here, okay, so we've got all these extra registers. And again, we'll talk through what all of these are over the next few videos. Now, we'll head down into the, in fact, before we do that, the one register we're going to be interested in the next video is going to be the stack. Okay, so that's a register up there for the stack pointer. Okay, so that's an extra register that we will talk about in the next video. Now, as I said, in order for us to get this, for example, the stack pointer to work, we have to be able to increment and decrement, that is, add 1 and subtract 1. So I've added an increment and decrement function into the ALU. So if we drop into the ALU here, you'll see that the ALU, although it looks roughly the same shape, you can see there's more functions. So the ALU previously, we had only 3 inputs, and we had a 3x8 decoder, and we could choose 8 different functions. So I've extended this, and I've put an extra line going into the ALU. This gives us 4 lines coming in. We then have a 4x16 decoder. It gives us 16 functions that we can do in the ALU. So it extends the ALU. Again, we'll go through the ALU extension and the changes in another video. It's just an overview that we're doing here. So you can see that if I zoom in a little bit, you'll see that we've got an increment and decrement function. So I've added this function in, which we will be using quite regularly with the stack. But we'll also be using it as a separate function as well, a separate increment and decrement function. Now we'll come out of this here, and let's have a look and see. We'll now drop into the control unit. Now the control unit is, if we zoom it down a bit, again it's still roughly the same sort of shape, okay? We're going to have our counter at the top, and I've decided to now call it a counter as opposed to the stepper. I've dropped the word stepper. So we've got our counter here, we've got our microcoded control unit here, so it's called microcode ROM, and we have our input instruction at the bottom. We have all our sets at one side, and all of our enables at the other side. Now, if you were to compare this to the previous iteration, which was in the last video, you'll see that there are a few changes here. But a lot of the changes are really quite cosmetic. I've just taken certain blocks and I've just added them in, okay, to and change the hierarchy a little bit. So let's open up the previous one, just have a quick look and see. So that's the previous version there. And if I drop down into, for example, the control unit, you can see in this previous version we have this block here, okay, and all I've done is I've taken this block here and I've stuck it into the counter. And there's also another block at the bottom, this block here, which counts, and I've added that into the counter section, so I've taken that up. And also at the bottom, the microcoded ROM at the bottom here, you can actually, if we can zoom in a bit, so the parts at the bottom here, I've taken this part here, the compression ROM and the actual microcoded control unit, and a couple of the blocks round about here, it's a little ladder, and also the splitter here, and I've taken these components and I've just put it into just one block for us. Okay, so if you head back in here, you can see I've just added it into the single block here and called it a microcoded ROM. Okay, so that's this block here. So an awful lot of it has been quite just like cosmetic changes to make the hierarchy look a little bit neater. But there are other definite changes which I have made, and again we'll go through each of the changes over the next few videos. So if we head down into the microcoded ROM, you can see here we've added in the compression and the microcoded ROM and all outputs in one level. It just keeps the whole thing a lot neater and tidier. So those are the kind of the main changes that we've made. But of course the devil is in the detail, and we will go through the details of this in the as we work through the next few videos. But obviously I want to show you the Excel spreadsheet that I used as well in order to generate the different parts of the program that we need. For example, we need to load up the microcoded ROM with the correct start positions, and we need the compression ROM with the correct start positions, and the microcoded ROM with the correct values for our sets and enables for each of the functions. So I'll open up that now and I'll show you that, but it's also in the resources section, so you can open it up too. It's the Excel spreadsheet. So let's have a look at that now. So this is the main Excel spreadsheet which you're going to have access to over the next few videos. Now in this spreadsheet we're going to use this in order to add in our commands. So for example, if we create a new command, for example, when we introduce the stack, we'll introduce a command called push and we'll introduce a command called pop. And we'll see how we can introduce those commands into this spreadsheet. And I've tried to make this spreadsheet as user-friendly as I can, although I mean it is quite detailed. But I will go through a video where we talk through it and how we can use it. But overall here, just to have a quick overview, first of all I'll get rid of my image here. Now the spreadsheet, if I was to make it a little bit smaller here, you can see it's actually quite detailed, okay? But really what we have along the top here, we have all of our possible output sets and enables, okay? So these come from the microcoded control unit, and then we just basically have all of our zeros and ones that determine the sets and enables for each of the instructions. And you can see the instructions here are in each of the rows. Okay, so the columns are going to be our sets and enables, and the rows are going to be our instructions. So for example, I could head up here and I could look at the this one here. It says the load instruction. Okay, so this is our load instruction here, and this is one individual load instruction, and you can see that it starts at position 4. So I've kept the idea of position 1, 2 and 3 as being our fetch, and then the other positions here, this is 4, 5, 6, 7, 8 and then a stop, is going to be the command for this particular load function. And you can see that there's a few load functions here. There's one here, and there's another load function, and another here. So it's 1, 2, 3. So there's 4 load functions that we've got here. And the reason we've got 4 is we've actually got 4 different addressing modes for these load functions. And again, we'll talk through the addressing modes in another video. So we've got loads to get through, and it's really quite interesting. And it's great to see how the addressing modes match in with the actual simple instructions and the kind of power that it gives us. So we've got these here, and as we build this up, what we do is we're actually just sticking in zeros and ones. So for example, we've got a reg A enable, reg B enable, there's a floating point unit enable, index enable. These are all our registers that they can be in and enable. And of course we've got our ALU values as well. We've got our memory address register, accumulator, and these are our set values. So we've just got a copy of all of these, and we've got all the zeros and ones we require for each individual step in order to work our way through a full instruction. So in effect, what we build up here is something called register transfer logic. And we'll look at how we can write some register transfer logic. And again, whenever we go through the stack, we'll go through the push and the pop, and we'll go in and we'll put these in, and we'll show you how we put them in. Okay, and we'll show you how we work out this register transfer logic. So this is the main spreadsheet that I use. You can see there's got options at the top here. So we've got generate hex. So basically what happens is if you add in a new instruction at the bottom, it'll have 4 or 5 lines. Then you can just say generate hex, and it'll go through automatically, and it'll generate all of the positions within the microcoded ROM. So you don't need to bother about how I generate that. Okay, if you want, you can always get in contact with me, and I can go through the actual VBA code if you're interested. But it's just an extra level of complexity that you don't really need to know for the moment. But this will generate all of our starting positions for our compression ROM, and it will generate all of our microcode for all of our individual instructions. Now just by pressing the one button. Now once we've done that, we can actually press the export microcode. So you click on that, and it'll export the microcode in hex, which we can load into the microcoded control unit, and we can export this the compression ROM. In this instance here, I've called it lookup. Okay, so this is actually the compression ROM. So we can export the compression ROM values as well. And we've got a final one here that just generates the instructions. So when I click on that, it goes through to another page, and this other page has just got a list of the instructions and not the opcodes. But we'll talk through this whenever we go to actually use it. Okay, so this is a main component in our design. But there is another component in the design, but we won't go on to that for a few videos, and that is the actual assembler. And as I said before, it's very important as we work our way through this design that we come from it in a couple of different ways. We come from it in terms of the actual connectivity and the digital design of our actual CPU, but it's also important that we come from it also from the angle of the assembler and the software. Okay, because we want to be able to write code that actually does stuff, and it's important we have a good assembler. So I've designed an assembler in Python, which is you know, it was quite a considerable feat for me. But I'll show you that again in the later videos as we work through that. So that's a whole other section. So we've got loads and loads still to get through. So we'll leave it here with this video, and we'll crack on in the next video, and we'll look at the stack and what the stack is and why we need it and how we build it into our design. So thank you for listening. I'll get you on the next video. Goodbye.